All right, good evening, gentlemen. We're going to start with the exponential function and the log function. So we'll start with the basics just to get some basic knowledge, just to backtrack a little. And if you look at what I'm looking at, the question that is on the slide, all right, it says that the graph of f of x is equal to 3x, 3 to the power x is drawn. And it says write f minus 1 in the form. So my first question to you would be, we are given f of x is equal to 3 to the power x. What does f to the minus 1 actually mean to you?
The inverse function.
Well done. So we want to find the inverse. So if we want to find the inverse, there's 3 steps. What is the first step in finding the inverse?
Reverse the x and
Swap
y.
the y and
Swap the y and... So if we look at the function we're looking at, it says f of x is equal to 3 to the power x. So if we swap that, what will it become? X is actually equal to 3 to the power y. And then we're going to solve, or we're going to bring this to y form. So in order for us to solve for an exponent, we're going to introduce a log. And we would say y is equal to log. The base is 3, that will stay. So we would say log x base 3. And then we can write it in inverse notation, which is actually equal to log x base 3. So we can see that the inverse of the exponential graph became, or an exponential function becomes a log function. Any questions there? So I think knowing the rules to find the inverse is extremely important. So we move on. Okay, so we got f minus 1 of x is equal to log x base 3. The second question is sketch the graphs of y equal to f to the minus 1 of x. So let's start with, we want to sketch the graph of the inverse. So the rule is, when you want to plot the inverse graph, all you have to do, golden rule, swap x and y. So if we look at the graph right now, we will notice that we have an asymptote, and the x-axis is the asymptote. And if we're looking at our y-intercept, it's sitting at 1. So any ideas how we're going to draw this graph?
so for the y-intercept, so you're gonna make x 0 and y 1. I mean y 0 x 1.
Okay, sorry, I'm just struggling with my pen a little. Let me just backtrack here a little. All right. So it's simple. Though if the y-intercept is 1, the inverse graph, if we're swapping that, that means that our x-intercept will become 1 for the inverse graph. And if you take any random point, as an example, if we take this point, and that coordinates there is 1, 3. So that point, remember we're swapping x and y, that point will become 3, 1. So 1, 2, 3. And there's your point 3, 1. And we know if the x-axis is our asymptote, so for the inverse graph, the y-axis becomes the asymptote. So putting all that together, and I'm just going to delete that now just to create a space to show you. And you'll notice our key points have moved and we've drawn the log graph. So there's f minus 1 to the x, which is equal to log x base 3. Okay, and just to remind you, that the y-intercept of 1 has now become the x-intercept of the log graph. And here's our point. We traced 1, 3 becomes 3, 1. And the x-axis was the asymptote. So now the y-axis becomes the asymptote. The question goes on to, it says, the next question is to find y equal to f to the minus 1 of x minus 2. Anyone can tell me what we're doing there?
The graph is being shifted 2 units to the right.
Well done. So we'll notice, in this case, we are shifting the graph 2 units to the right. So remember, x is equal to 2. That's a change of sign. So it means that this point that we're seeing sitting at on the x-axis at 1 has to move 2. I'm going to change my color quickly just to show you. So if we jump 2 units, that point should move there. And this point, which is sitting at 3, 1, will also move 2, 1, 2, and that will move there. And then, if the y-axis is the asymptote, that's also going to shift 2 units. All right, which makes the new asymptote sit at x equal to 2. So we're going to put this all together for you. So you can see all the points, as I showed you, from 1, it moves to 3, and all the points have shifted 2 units to the right. And the last question is to use your graphs to solve for x, where the log of x minus 2 to the base 3 is less than 1. So we have drawn, that graph is represented by the green graph, and we want to know, when is this graph less than 1? Any ideas? Okay, so just to help you out, this is the line y equal to 1. So what we're trying to do is determine, when is this graph, the green graph, below 1? And that's the point we're trying to trace there, right? And you'll notice I'm redrawing it for you. So it starts from an x value, which is sitting there. And that x value we said was 1, 2, 3, 4, 5. So the x value here is 5. So we can say that x less than 5 would be our solution. But we govern by the asymptote sitting at this point called 2. So if we look at that point called 2, that's where our asymptote is actually sitting. So our answer would be x is an element from 2 to 5, or we could say x is less than 5, but greater than 2. And the reason why we have to stop it at 2 is because we have an asymptote sitting at 2. Any questions there?
Sorry, sir. I don't
That's
think I
just
understood that last part, sir.
sorry.
I don't think I understood that last part, sir. Can you please explain it one more time?
Yeah. Okay, so the question says, when is the log of x minus 2 base 3? Now remember, that is the green graph. Okay, let me just take out some of the writings I have here. Okay, so the question wants to know from us, when is the green graph less than 1? So we drew the line y equal to 1. There's our line y equal to 1. Now, when is this green graph below the line y equal to 1? So it starts at this point here, and this point is actually 5. So can you see it's below it? And it carries on. But it's stopped by this asymptote sitting here at 2. So therefore, our answer would be x is less than 5, but greater than 2.
Oh,
Okay.
thank you, sir. I understand, sir.
So we're now going to move on. if we look at this, given f of x is equal to 2 to the power x, g of x is equal to f of x minus 2, and h of x is the inverse. Write down the equations of g and h in the form y equal to. So let me give you a minute. Let's see what you would get. So remember what the question is. Write down the equations of g, which is f of x minus 2, and h, which is f of minus 1 to the power x. Let's give you a minute to be able to do that. Okay, so we're going to start with f of x is equal to 2 to the power x. All right. Now, what I want to ask you guys, oh, sorry, my slide just jumped. So the first one is to find g, they are replacing, in other words, to find g, they're saying f of x minus 2. So where does the x, we're going to replace it with, there's your x, we're going to replace it with x minus 2. And that represents g. Then to find the h graph, now they're telling us to find the inverse. So to find the inverse of a graph, remember what we said, step 1. If you got f of x is equal to 2 to the power x, that's our original. So in finding the inverse, step 1 is to swap x and y. So there's our y, f of x becomes the x, which is actually equal to 2 to the power y. And then because we have a y, we're going to bring it to log form, which is y is equal to log, the base is 2x. So we have log x base 2, which represents now your inverse. So there's our f to the minus 1 of x, which is actually equal to log x base 2 . And remember, this is represented by h of x. Okay, so that's a basic question on logs. Let's go a little deeper now. Okay, I'm going to jump and skip all that because I wrote it down for you. Okay, then the second question is to draw, which we've done in the previous question, so we're going to put that on hold, all right? So I'm going to skip that one as well and come now to the past paper question. So let's look at the first challenge we have. Okay, this question is from the Practice 2023. The DOA sent a practice paper, so it's a good paper that we could look at. So I'm going to give you some time. Let's give you a minute to get this question started. After a minute, we will come together. They say a minute to make it, all right? Let me know when the first person is done. Anyone's got an answer for the first 6.1? Mr. Walton?
So can you just tell us where you like get started and then
Oh,
try to go
that's a
from there?
good point. If you don't know where to start, we're just wasting a minute. All right. So let's read the question. The drawing below represents a graph. So there's the equation given. Log x base a. And they give us a point. Remember, point will always represent xy. It's a point on the graph. The question is to show, in other words, the question is to find a. All right. And they're giving us the answer that a is equal to half. So let's start, Mr. Walton, with the equation. F of x is equal to log x base a. So remember, I'm going to now substitute this point here that you see. The y value is minus 2. The x value is 4 base a. My goal is to try and find a. Now, to find a, we are in log form. We're going to bring this to exponential form. So exponential form means take your base, which is a, to the power minus 2 will equal to 4. So now I want to solve for a. There's two ways I can do it. One way is to say a to the minus 2 is actually equal to 1 over a squared, which is equal to 4. And let's write 4 as a fraction, 4 over 1. By cross multiplication, 4 times a squared is 4a squared. 1 times 1 is 1. And now we get a squared to be equal to divide both sides by 4, 1 over 4, finding the square root of 1 over 4. And remember, when we find the square root, it's always a plus minus, and we're going to take a to be positive half. Okay, 1 over 2. So we're going to put that into the equation. And now it means that our actual equation, remember the question was to find that a is half. We're done. How do we know positive? Well, we're showing it. The answer was given. Another thing I want to say here is, remember, now that you have a, you're going to use a in this equation for the rest of the questions. Even if you got it wrong, you can use the a. Okay, let's go to the next question. Determine the equation of the inverse. So I'm going to give you a minute. Quickly find the inverse for me. Let me know when you're finished. A minute. People, I don't want you to be watching me. I want to work with you. So I hope you've got a pen and a page and you're working and not just watching the video. If you just watch the video, you're going to learn nothing. So you're going to work with me. Anyone found the inverse?
Would it be 1 over 2x?
Oh, let's check if you're right. So there's our equation. Step 1 in an inverse is swap x and y. So f of x represents y. And if we swap it, it becomes x is equal to log x base a, but we found a in a previous question to be half. Oh, sorry, I forgot to swap the actual. That should be y. Okay. So remember, I need to bring this to y form. And the only way for us to do that is to change this to exponential form. Okay. So we can say y, which is equal to the base, is half. And remember, this represents your exponent x. So we have y is equal to half to the power x. That is the inverse. They said leave it in y form. So we can leave it, or we could actually change it if we want to a negative power, 2 to the power minus x. But there's no need to do that. We can leave it as y equal to half to the power x. All right, let's get to 6.3. The next question is, write down the reflection of h. If h is the reflection of f, in the x-axis. Remember, f now is represented by log x base half. So we're reflecting on the x-axis. Remember, your x-axis is positive, negative. So if we're reflecting on the x-axis, we're placing our mirror on the x-axis, and on your y-axis, there's your plus, and there's your minus. So if you're reflecting on the x-axis, it means y is going to change its sign. Okay? So anyone got an answer for me?
So the x-intercept, would it stay the same? So it would still be 1, and then it would just be flipped over.
We're not interested in the x-intercept. If we're
Yeah.
reflecting on the x-axis, remember the rule?
Oh, sorry. Yeah,
And
okay, I
y
see.
will
Sorry.
change its sign. It'll become a negative, all right? So basically, f of x, as you can see it, that becomes a negative. But we don't like f of x to be represented, so we transfer it over onto that side. And that will give us f of x is actually equal to negative log x base half. That will be our answer. Any questions on that one? Yes? No? Maybe?
No,
No, sir.
sir.
Okay.
Sorry, sir.
So you can see the basics question that we are dealing with.
Sorry, sir.
Sorry.
So when you're reflecting on the x-axis, do you just make y equal or negative? And if you're flexing on the y-axis, you just make x negative.
Good question. Let's go a little bit deeper into that. Let's make a note of that. It can come out in any graph, not just this graph. Two reflections that we deal with most of the time. So if we reflect on the y-axis, what's the rule? We make the x negative. Does that make sense? So if we had a question like this, y is equal to 2 to the power x, and if we reflect, what will that become?
2 to the
Wait
negative
for you.
x, yeah?
Well done. 2 to the, so y would be equal to 2 to the negative x. But if we take the same question and we reflect on the x-axis, what will this now become? The negative now comes in the front. Does it make sense, or the difference between the two reflections? Remember, when you
Yeah,
reflect on the
makes sense, sir.
x-axis, the y becomes negative. Any questions on that?
No, sir.
Okay. I'm going to come back to 6.4. I have to do a little bit more. Remember for me to come back. I just want to get a little bit to the basics first and then come back to that. All right. So if we look at this question now. Sketch below is the graph of P of X is equal to, let me just get my pointer out for you. Sketch below is the graph of P of X equal to A to the power X. The graph intersects at the y-axis at A. So that is our y-intercept. And we're given 1 point to be 532. So the first question is write down the coordinates of the point A for 2 marks. Give you some time. One minute. All right, anyone got an answer for me?
1, sir.
Out of 2 marks, we'll give you 1 out of 2.
So it is 0, 1.
So let's see how we actually get that now, right? So remember, there's our equation. If P of X is equal to A to the X value at this point is 0. So our Y value is P of X is representing Y is equal to A to the power 0. Any number to the power 0 is what? 1. And if it's 1, we have now coordinates to be 0. Okay. So if we look at the next question, it says calculate the value of A. Let me give you a minute for that question. Okay, anyone got an answer for me?
2, sir.
Somebody said 2. Can we have an agreement for 2?
Yes, sir.
There's an agreement for 2. Okay, so let's quickly look
Yes, sir,
and
it's
see how
2.
we. So lots of people are saying 2. That's good news, all right? So if we got P to the X is actually equal to, now in the previous question, oh, we haven't found it, A to the power X. We have 1 point in the graph given. There's a point we want to use, XY. So we're going to replace P of X, which represents Y, with 32, which is equal to A, we don't know, but we know that the value of X is 5. And then we basically find A to the power 5, so we're going to find the 5th root of 32. And if you find the 5th root of 32, you should be getting 2. So there, that's how we get our A to be 2. All right, let's go to the next question. 1 mark. Write down the domain. Domain represents X of P, which is this graph. Is there any restriction? I mean, if we go anywhere on the X-axis, we'll always get a point, am I right? Are we in agreement? What
Yes,
do you
sir.
think?
Yes,
What do you think is the domain of this?
so it would
X
not
is
just
an
be X.
element of real numbers.
Thank you. X is an element of reals. Okay. Can be anything. But while we're on it, let's talk about a range. What would be the range of this graph? Since the domain was so easy.
So y is greater than 1, means 0.
Well done. So on an exponential graph, it's going to be either y is greater than equal to, sorry, not equal to, y is greater or less than the asymptote. In this one, the asymptote is the x-axis, as you can see. So y is greater than 0. It cannot include 0. All right, so we know our value of a was 2. We've got our domain, we've got our range. We can move on. 7.4. So that's such a common question. Now remember, from the previous question, we now have P of X is equal to 2 to the power X. The question is now to find the inverse. Let me give you a minute. Quickly find the inverse for me. Anyone's got it?
Y is equal to log X base 2.
Okay, step 1, swap X and Y. So that will become X is equal to 2 to the power Y. And then Y will be equal to log, the base is 2. So it's log X base 2. Correct, that is our inverse. All right, now we come to the question that I skipped in the previous one because this is a little easier. and then we'll go to the previous one. They want to know, determine the values of x for which the inverse, now remember this is the inverse, is less than or equal to 5. So in doing a question like this, we know what's p to the minus 1, all right? It's actually log x base 2. So equate it to 5 first. And if we equate it to 5, we want to find, remember we're finding the x value. So to find the x value, we bring it to exponential form. So the base is 2 to the power of 5, and there's our x there. And if we solve that, we're going to get x is equal to 32. Now, remember, the inverse represents a log graph. So what we're now saying is that x is less than and equal to 32, but we will be stopped by the asymptote. So it has to be greater than 0, because the asymptote here is the x-axis. So the asymptote of the log graph, which is the inverse, will become the y-axis. So we have to stop it at the asymptote, and you cannot include the asymptote. Okay, that will be the asymptote. Any questions?
No, sir.
Gentlemen, I just want to tell you, I'm not making up these questions. These are all past paper questions. You need to rise to this level or we are all in trouble, okay? So I want to go back to the question I left out now. All right, and this was the question, okay? So using the same technique, I just want to delete some things here, right? So we're looking at 6.4 that I left out. Some of you were maybe thinking I was running away from it. I was, but now I ran back after we got some foundation. Remember, we did find A in this question. For 6.4, A was half. So I want you quickly to try out 6.4. We'll give you a minute. All right, anyone got an answer?
0 is less than x, which is less than equal to, minus 3 is less than equal to x.
All right, he says
Okay,
X
so
is
I
less.
calculated to be minus.
Sorry, young man, tell me your answer here again.
So I calculated x to be minus 3, but not exactly sure on how to calculate it.
All right. So remember what I said, step 1, you take the graph equation, x plus 4, and you say, let's equate it to 0. Step 1. All right, now we're going to solve for x. To solve for x, we must bring it to exponential form. So remember, the base here is half. So we're going to say x plus 4, and the base is half. And this represents the exponent. So any number to the power 0 is 1. So we're going to get x plus 4 is actually equal to 1. And if we solve for x, what do we get? Minus 3. Are we all in agreement? And remember from the previous question, so we are now saying x is less than and equal to minus 3. Oh, sorry. My pen is going a little bonkers at this stage. So we're going to use our minus 3, but it has to be greater than the asymptote. Remember, yeah, we need the asymptote. Okay? So the graph you're seeing on the top, the asymptote is on the y-axis. Okay, remember this is y equal to log x base half. But if we look at this equation, what are we doing to the graph? In terms of transformation. If we compare
So aren't you just looking at 4 to the left, sir?
4 units to the, thank you. The translation from here to here, if we solve for x here, it's -4. So this graph is shifted 4 units left. So if the asymptote is at 0, where will the new asymptote now move to? Will it be -4? Because we
Minus
moved
3,
it-
sir.
How you got 3?
So you said the new asymptote. So if it was at oh, never mind, sorry.
Very
Got it
good.
wrong.
Okay, so the asymptote is sitting at 0. Okay, x equal to 0. As you can see, let me draw that. Some of you have not seen that. There's the asymptote right here. And we're going to shift it 4 units. And if we shift it 4 units, it should be coming to the point -4. So it should be greater than -4. And there's our solution. Are you happy with that? You'll notice that the last part of the question seems to be always challenging. So it'll go quite easy. 6-1, 6-2, 6-3, and 6-4 is this level of question. But don't worry, if you don't catch it, you can watch that video again a little later. Okay, so now we'd like to look at a combo question. Okay, and in this combo question that I chose, we have an parabola, oh, sorry, not a parabola actually, a hyperbola intersecting with a log graph. Quite interesting question. Okay, so let's get into it. If you want to find this question, you'll find it in a November 2017 paper. Okay, so if you're on the Teams group, I pulled this one out from November 2017. You can actually look at it there, or you can actually download it from the DBE website. All right, so the diagram shows the graph of g of x 2 over x plus p. Now remember, p represents an asymptote, which is the vertical, and then we have q, which represents the horizontal asymptote of the hyperbola. As you can see, there's one part of the hyperbola, there's a second part. They're also giving us a log graph, f of x equal to log x base 3, which you can see. All right. Y is equal to -1 is the horizontal asymptote of g. So if y is equal to -1, what does that represent on the equation? Somebody help me out. Somebody.
So won't it be the Q values?
Thank you. Perfect. All right. So remember, the q value is now given to be -1. My computer is just jumping there. Being quite forward today. So remember, we are saying that the q value here is equal to -1. Then they gave us B10 is the x-intercept of f. Okay, so that's the x-intercept of f. Then T1 is a point of intersection between FG. Okay, we don't know, we know the y value is 1, but we don't know the x value. The vertical asymptote of G intersects the x-axis at point E. We don't know what point E is, but we know B is 1. But they tell us OB, very important point. If OB is equal to BE, who can tell me what point E is now?
2, sir.
Sorry?
It's going to be 2, sir.
It's going to be 2. Well done. Okay, so we can make a note of that. The first question is write down the range of G. So what graph is G?
Hyperbola.
Hyperbola. All right, everyone's got that? If we look at G, here's our G graph. And we know in an hyperbola range, it's a standard equation where you will say y is an element of reals, except for y is not equal to, and it's really giving me a hassle now, the asymptote. And what is the asymptote for the hyperbola? Anybody knows?
-1.
Ish, how you got
-1.
how you got -1? Anyone know how you got
It's given,
-1?
sir.
It's given. That's why. There's he's looking at it right here. Can you see that? That's the asymptote. Okay. So y not equal to -1. The next question is to determine the equation of g of x. All right, there's my g of x. So I'm going to take it from there. G of x yeah, let's change the color. Maybe my red ink is running out. So g of x is equal to, it's 2, as you can see it on the top. I'm actually looking at this. Over x plus p. So do we know the vertical asymptote there?
Yes, sir.
What is the vertical asymptote?
0, 2, 0.
Okay, all I need to know is that x is 2. Can everyone see? This is the point E that we're looking at it, and its value is 2. So we're going to change the sign and make that x minus 2. We also worked out the horizontal asymptote in 5.1, and that we said was -1. So there we have it. G of x is equal to 2 over x minus 2 minus 1. Any questions how we got that?
No,
We
so
all good?
all good, sir.
All right. Well done. If you're all good, it means we can move on. Okay, the next question. Now, please write the question, the equation down because we're going to need it for the next one. Remember, g of x is equal to 2 over x minus 2 minus 1. Now it says calculate the value of t. Let me give you a minute to work that out. Okay, I have to take you back to make a very important point. Remember that we have A, which is sitting as a point of intersection, which is sitting on the log graph, and it also sits on the hyperbola. So we can use any equation we want to actually solve for that. So if you haven't written down the log equation, it's f of x equal to log x base 3. So just to get you started, we can use either y equal to log x base 3, or we could use the one we just found, which is your g of x equation. G of x is equal to, in the previous question, we found that to be 2 over x minus 2 plus 1. So what are we saying? To find t, remember A is a point x, y. So the x value is t.
Sorry, sir.
Yes.
Was it
T
not
is equal to 3.
-1? So was it not 2 over x minus 2 minus 1?
Oh, could be.
-1.
Did you write that down? All right. Thank you for that, Mr. Walton.
Yes, it
At
was
least I know
minus.
somebody, at least I know today somebody is awake. Right, let's erase that. That should have been a -1 from the previous question. It's coming through. Okay, so what we're saying is if point A is T1, T is represented by X, and Y is represented by 1. So we're going to substitute that. So we're going to say 1 is equal to, here goes my pen again, struggling to write today. So where we have X, we're going to represent that by T. Where we got X, we represented 3 to the base 3. So that's going to help us to find T. So to find T, we got to bring it to exponential form. The base is 3 and the power is 1. So we can say T is equal to 3 to the power 1. Power 1 is actually 3. Or we could use the other one. Where you got g of x, you would represent that by 1, which is actually equal to 2 over t minus 2 minus 1. So we can solve for t on this equation, which is much more difficult to solve, right? It's an LCD question. So you have two options there. Any questions? So remember now that we found t, we can replace that point and put its proper coordinate. So I'm going to get my eraser out now. And let's write down and make a note right there that t is 3. Okay, let's go on to the next question. It says write down the inverse of f. I think we did enough inverse questions, am I right? So we can skip that. Oh, but we need it for 5.5. So let's quickly do the inverse of f. Remember, f is equal to log x base 3 So we're going to do the inverse of x equal to log y base 3. Then we're going to write in exponential form. We're saying y base is 3 to the power x. So you notice that the inverse of a log is now an exponential equation. And then the last question there says for which values of x will the inverse, now remember we're talking about the inverse here, would be less than 3. So we're going to take the inverse. Remember that is the inverse. When is that less than 3? Well, this is now an exponential equation. The bases are the same. So we can drop and say x is less than 1. And that would be our answer. Any questions at this stage?
Was it?
So would it not also be greater than 0?
Good question. I was waiting for that question to come up. No, it won't, because the log graph is given here. Remember, the inverse is going to be looking like this. That's an exponential graph. Okay? So the asymptote is, on this case, if you're looking carefully, where's your asymptote sitting? Before I answer the question.
Y is equal to 0.
Yes. So there's no restriction on the x-axis. Can you see? It's going on to infinity. So we have the range that has a restriction here. Okay? Y is actually greater than 0. The range is affected, but not the actual domain. And then we come to the last question. 5.6. Determine the point of intersection. How do we find points of intersection?
Equate the graphs.
Yeah, but there's a catch here now. Let's go a little deeper. Let's see what's the catch here. Determine the point of intersection of the graphs of F. All right, there's our F. And the axis of symmetry of G. So we need to know what is the axis of symmetry of G. So that has a negative gradient. Now we did this yesterday. If you was in yesterday's lesson, now remember G of X right now, that equation we found earlier, which was 2 over X. Can someone remember the equation? Mr. Walton, you
2
corrected
over
me earlier.
x minus 2
X
minus 1
minus 2
minus
minus 1.
1.
Now, the axis of symmetry with a negative gradient is y is equal to minus x plus c. Would you agree with that? Yes or no?
Yes, sir.
Okay, because it said negative gradient. How do we find the c value of this graph?
The intersection of the horizontal and vertical asymptotes. That
Okay,
counts as a point.
just to show you a picture of what I'm saying here. Okay, my question is how we find c. Which point would we substitute for c? We
So
have
we
to
sub in
substitute.
D, sir. Sub in D,
Sorry?
sir. Sub in D, sir. Point D.
Yes, which is the intersection of the asymptotes. Remember, there's our asymptote here sitting at 2, and there's our asymptote sitting at 1. So we're going to sub in this value here. Can you quickly sub it in for me and tell me what you get?
1, sir.
Okay, let's confirm that. So we got y to be minus 1, which is equal to minus into 2 plus c. Minus 2 goes on that side, becomes a plus 2, and we end up with c to be 1. Are you happy with that?
So,
Yes, sir.
Okay. Basically, your equation here is y is equal to minus x plus 1. Are we all in agreement? Yes or no?
Yeah,
Yes,
all good, sir.
sir.
Some of you are doubting this. All right, now, what is important here is you'll notice that, okay, we want to find a point of intersection of this and the log graph. Okay, so we can equate both if we want, which is one of the ways you can actually work with it. Or, what is the x-intercept of this graph? Who can tell me what the x-intercept of this asymptote is?
So it'll be 1, sir.
It'll be 1. We let y to be 0, okay? So we're going to get 1, 0. But where is 1, 0 on this graph? Isn't B representing 1, 0?
Yes, it is, sir.
So don't they both intersect at this point 1, 0? Because that is the x-intercept of the straight line, which has a negative. Basically, it's going to look like this. Okay. So the x-intercept of this graph is 1, 0. And that's also the x-intercept of the actual log graph. Okay, so we have completed that question. And I'm now going to just want to stop the recording.